We often wonder how camera was invented or the concept of it came to light. We have found answer to this question. The basic principle of camera was found by Abu Ali al-Hassan Ibn Al-Haytham. As far back as 1000 AD, a prominent figure during the Middle Ages invented the first pinhole camera called the camera obscura. This device was a box that was able to project an image of its surroundings onto a screen. Abu Ali al-Hassan Ibn Al-Haytham is known as father of optics. The Arab Muslim scholar Abu Ali al-Hassan Ibn Al-Haytham, known in the West as al-Hasan or Alhazen, was born in 965 in the city of Basra in southern Iraq. Hence he is also known as al-Basri. When he was educated in Basra and Baghdad and died in Cairo, Egypt in the year 1040, Ibn al-Haytham, known in the West as Alhazen, Ibn al-Haytham was the first person to test hypotheses with verifiable experiments, developing the scientific method more than 200 years before European scholars learned of it, by reading his books. Ibn al-Haytham proved that light travels in straight lines, gave the first clear description and correct analysis of the camera obscura and pinhole camera, and built the world's first camera obscura, developed a highly successful theory which explained the process of vision as rays of light proceeding to the eye from each point on an object, which he proved through the use of experimentation. He is described as the world's first true scientist. He is also considered to be the founder of experimental psychology for his approach to visual perception and optical illusions. Why is he called the father of optics? Because Haytham is credited with explaining the nature of light and vision. He carried out experiments using a dark room he called al-Bayt al-Muslim, or camera obscura, the device that forms the basis of photography. His experiments inside a dark room explained that light travels in straight lines. Camera obscura. A camera obscura is a dark room or box with a small hole that projects an image of the outside world. The term comes from the Latin words camera meaning room and obscura meaning dark. How camera obscura works. Light reflects off objects outside the camera obscura. The light passes through the hole in the camera obscura. The light illuminates the surfaces inside the camera obscura with an image of the outside view. The image is inverted, upside down, and reversed, left to right. Use of camera obscura. Artists used camera obscuras to make accurate sketches of scenes like landscapes or architecture. Astronomers used camera obscuras to study eclipses without damaging their eyes by looking directly into the sun. Difference between camera obscura and a modern camera. Camera obscura does not record the image, whereas a modern camera does. The camera obscura is considered the early precursor to the modern camera, as it demonstrated the basic principle of light projection through a small opening, which is the basic principle of modern camera, and without the knowledge of camera obscura, modern cameras would not have been possible. Theory of vision by Ibn al-Haytham. Unlike previous theories, Ibn al-Haytham argued that light from external sources enters the eye, not the eye emitting rays to see objects. He used the camera obscura concept to explain how light travels in straight lines and forms an image on the retina, demonstrating this with experiments. Ibn al-Haytham's theory of vision, also known as the intromission theory, states that vision occurs when light reflects off an object and enters the eye, essentially proposing that light travels from objects to the eye, rather than the eye emitting rays to perceive objects, which was the prevailing belief at the time. He is considered the father of optics for this groundbreaking discovery, detailed in his work Kitāb al-Manāẓir, Book of Optics. Ibn al-Haytham's theory of light and vision is neither identical with nor directly descendant from any one of the theories known to have previously existed in the antiquity or in Islam. Theory of light. Ibn al-Haytham's theory of light, considered revolutionary for his time, stated that light travels in straight lines, originates from luminous objects, and reaches our eyes by reflecting off objects, essentially explaining that we see things because light rays bounce off them and enter our eyes, not the other way around. This theory was based on extensive experimentation using a camera obscura, darkroom, and laid the foundation for modern optics. Ibn al-Haytham's theory of light and vision is neither identical with nor directly descendant from any one of the theories known to have previously existed in the antiquity or in Islam. The first real appreciation of the action of a lens, in particular the ability of a convex form to produce a magnified image of an object, appears to be credited to Ibn al-Haytham. It was not until the late 13th century that spectacles were invented, representing the first practical use of magnification in society. Ibn al-Haytham made a thorough examination of the passage of light through various media and discovered the laws of refraction. He also carried out the first experiments on the dispersion of light into its constituent colors. Ibn al-Haytham's 7-volume treatise on optics, Kitāb al-Manāẓir, Book of Optics, which he wrote while incarcerated between 1011 to 1021, which has been ranked alongside Isaac Newton's Philosophiae Naturalis Principia Mathematica as one of the most influential books ever written in physics, drastically transformed the understanding of light and vision. Mathematics. In mathematics, Ibn al-Haytham built on the mathematical works of Euclid and Thabit ibn Qurra, and went on to systemize infinitesimal calculus, conic sections, number theory, and analytic geometry after linking algebra to geometry. His contribution to mathematics was extensive. He developed analytical geometry by establishing linkage between algebra and geometry. He studied the mechanics of motion of a body, and was the first to maintain that a body moves perpetually unless an external force stops it or changes its direction of motion. This is strikingly similar to the first law of motion described centuries later by Isaac Newton. His work on catoptrics in Book 5 of the Book of Optics contains the important problem known as Alhazen's problem. It comprises drawing lines from 2 points in the plane of a circle meeting at a point on the circumference and making equal angles with the normal at that point. This leads to an equation of the 4th degree. This eventually led Ibn al-Haytham to derive the earliest formula for the sum of 4th powers, and by using an early proof by mathematical induction, he developed a method for determining the general formula for the sum of any integral powers. This was fundamental to the development of infinitesimal and integral calculus, field of medical science. Ibn al-Haytham was the first to describe accurately the various parts of the eye and give a scientific explanation of the process of vision. In medicine and ophthalmology, Ibn al-Haytham made important advances in eye surgery, and he studied and correctly explained the process of sight and visual perception for the first time. 19. He described in detail the various parts of the eye and introduced the idea that objects are seen by rays of light emanating from the objects and not the eyes, as was popularly believed. Sight perceives the light and color existing on the surface of the contemplated object. Vision perceives necessarily all the objects through supposed straight lines that spread themselves between the object and the central point of the sight. Ibn al-Haytham is considered by some to be the founder of psychophysics and experimental psychology, for his pioneering work on the psychology of visual perception. He dealt at length with the theory of various physical phenomena like shadows, eclipses, the rainbow, and speculated on the physical nature of light. He also attempted to explain binocular vision, and gave a correct explanation of the apparent increase in size of the sun and the moon when near the horizon. He is known for the earliest use of the camera obscura and pinhole camera. 11. As stated above, he contradicted Ptolemy's and Euclid's theory of vision that objects are seen by rays of light emanating from the eyes. According to him, the rays originate in the object of vision and not in the eye. Through these extensive researches on optics, he has been considered as the father of modern optics.